Hello, my name is Chang-Ho. My presentation title is Correlation Analysis of Geomorphological Characteristic and Debris Flow Impact Pressure. Content is Introduction, Methodology, Results. First, Introduction. Currently, slope disasters are increasing a lot due to abnormal climate heat at home and abroad, and especially debris flow is causing great damage to human life and social infrastructure. In Korea, the probability of landslides during typhoon and torrential rain is greatly increasing. In particular, more than 70% of the mountains area is vulnerable to landslides. When analyzing the number of buildings damaged by landslide disaster type from 2011 to 2020, the number of buildings damaged by debris flow was about 4 times more than that of steep slope crop. In order to predict and evaluate such debris flows in the future, it is essential to analyze the topographical characteristics and triggers factors of existing debris flow area. Therefore, a correlation analysis was performed with the topological characteristic according to the impact pressure and the low to high criteria were presented using the cumulative distribution probability. Next methodology. The empirical method calculates the maximum velocity and height of the debris flow for each region based on spatial data and empirical formula. The numerical analysis method performs inverse back analysis through partial data and numerical analysis program to determine the maximum velocity and the maximum height of the debris flow for each region through quantitative analysis. Analyze and calculate impact pressure based on the correlation analysis was performed with the geomorphological characteristic of the debris flow disaster area. There are several geographic features as this figure trigger factors that are correlated within debris flows. First, initiation area is start of debris flow. This mobility index expressed by Burson to indicate the ability of debris flow to flow through the center of gravity. This delta H and the difference between the elevation of initiation of debris flow and the elevation of the sedimentary site. This is L is the horizontal distance between the debris flow generator and the deposit area. This travel distance from the start of debris flow to the deposit site. Travel angle average slope from the start of debris flow to the sediment. This is pale scored area as sedimentation begins. Uh, Correlation between impact pressure, Zanchetta and QE, topographic factor and vulnerable factor was reviewed. The range of the impact pressure of the debris flow varies according to various formula, so it was determined through correlation analysis of the respectively empirical formula. The proposed formula of the QE and excluded due to poor correlation, and the correlation analysis was performed with the proposed is for Zanchetta. In all cases, R square is Zanchetta was high. The runout distance was 0.69. Catchment area is 0.67. Travel angle 0.72. Mobility index is 0.46. And travel area is 0.6. These three grades of low, medium, high were proposed. This figure impact pressure as cumulative distribution probability, and it was analyzed that low was 0 to 152 kilopascal. Medium was 152 to 249 kilopascal, and high 249 kilopascal or more. This is B. Mobility index is mobility index 0 to 3.6, 3.6 to 5.5, and the high is more than 5.5. This is C is triangle, the debris flow as a cumulative distribution probability, and finally D is catchment area distribution probability or analyzed. Low was 0 to 28 to 100 and to this value. And this using the three grade divided using cumulative probability distribution. This pure correlation analysis was performed between the impact pressure, which is hazard intensity, and mobility index, cause the debris flow, the travel angle, and the travel area. This is A is analysis of the correlation between impact pressure and mobility index. The coefficient of determination of the empirical method was 0.61, and the coefficient of determination of the numerical method is 0.86. This is B, correlation analysis between impact pressure and travel angle. The coefficient of determination of the empirical method 0.75, and numerical method is 0.86. And C, correlation analysis between the impact pressure and the travel area. The coefficient determination of the empirical method was 0.84, and numerical method is 0.77. Through this analysis, it can be determined that the hazard intensity analysis through to numerical analysis method is more reliable value than the empirical method. And it dropped that the more precise analysis of debris flow through the numerical analysis method is needed. The hazard intensity of debris flow is calculated through empirical and numerical method was analyzed. If applied and multiplied outside the study area in the future, it is expected to be used basic data and for lab and slice parameter assessment. Thank you.